everyone, welcome back to our YouTube channel, Becoming a ROS Developer. Today we have one of our students, Francois, who has completed our course, NAv2, ROS2 Navigation in 5 days. And in this online course, at the end of the course, you can complete a real robot project, which is a project where you have to apply autonomous navigation onto a real robot here at the construct. So that's what we're going to be seeing here today. So hello, Francois, how are you?
I'm fine, and you?
I am great. I'm very excited to see your um, your presentation. So please, whenever you want, start sharing your screen and just show us how you've done this project.
Okay, so here we go. Should see my screen right now.
Yeah, I can see myself actually.
Okay, so here we go. So
Okay,
I've set up a few small presentation using the format that you use for the courses.
oh
So
great.
it's going to be based on that. Okay, so this project is consisting of four sections, and the final goal of this project is enabling a mobile robot to move to a named location. The presentation is going to be that way. We're first going to demonstrate that we have reached this goal with the real robot. Then after, we will have a step-by-step explanation of how we reach this goal. First with a simulated robot, then the adjustment that we have made to make it work with the real robot. And we'll have a small Q&A session. So I've got everything set up here to demonstrate what we do have when we have this thing running. So here we go for RViz, which is the thing that we have to display. Uh, it's our user interface, basically. Whoops, what's going on?
I think you clicked the popped on another tab.
Ah, okay, so whoops, dismiss. Okay, so now we're starting the localization. Basically, this node is localizing the robot in the environment.
Mm-hmm.
So here we go. We have our robot in the environment, and then we start the navigation planning. So now we have our robot, but it is not placed how it should be. So we place it in the environment. So here is, whoops, 2D pose. This is our starting point. Whoops, should be good. Then we send our robot to a destination that is called corner one, that is here in
Uh-huh.
this. So we start, and we have the feedback from our node as the robot is moving to the destination, and for some reason, oops, something went wrong.
I think it's not localized correctly. It looks like something might be happening in the
No. Mm-hmm.
localization. So maybe um, you don't have to kill anything.
To, yeah.
You can just set a different 2D estimate. Are you sure that's where it's at?
Yes, it is. Whoops, it is. Now it is there.
Because you
Oops.
see how it's not lined up correctly, the
Yeah,
lidars with the.
should be. No. Whoops. Um,
Hmm.
what's going on? This is a demo effect, you know?
Yes, that is why it's even better.
Ah,
There we
okay.
go.
No,
That's
ah,
better, but I don't
yeah,
understand why the
yeah,
lasers.
because it was at the right place. It was at the same place in the map and as in the display. So if we restart, the robot is moving, and now it is getting to the right place, getting the right orientation.
And it's attempting. Oh, there we go.
Yeah, here we
Navigation
go. So we're
succeeded.
finished. So how we've done that. So this is what I'm going to try to explain as better as I can. Okay, basically we started with the simulated robot. This is what you saw is the final product,
Hmm.
but basically we started with the simulation robot, for which we had two utilities that we used. We used the launching of the simulated robot that is here, but we will not show that anymore because, and we used RVS basically through the few steps that we've been working. We start with the default setting, then the first step was the mapping. So we have added a few items to the mapping.
Mm-hmm.
We have added our robot model, TF, the laser scan, then the map. In the second section, we have added the things that are related to the localization, the pose with covariance, and the particle cloud. And we, at the last section, we add the things that are related to path planning, basically the path of the robot. We saw that green line and the local map and the global map.
Mm-hmm.
Okay. But first of all, we needed to add a map. So the very first step was to build this map. Okay, we use a node that was called a cartographer to draw the map from the oneirometry and the laser scan data. And since the working area is very small, it's 2 meter by 2 meter, we have improved the resolution of that map in the launch file from 5 centimeter to 1 centimeter. And when we have started this cartographer, we used the teleop twist keyboard node to drive the robot in the environment until the map was pretty well defined. And after we saved the map when everything was pretty good. So we have a small, fast video of this operation here. So we start
Nice.
the mapper, we move around, and the map is getting better as we go in the environment. You see the resolution of every object is getting better.
Mm-hmm.
Then everything is pretty good right now. We just save the map. So this is what we've done to have a good map for our robot to go to. We have done the same thing with the simulated robot since the environment is somehow slightly different. Then we have recorded the points that we needed for our script to go to various poses. Basically, for this, we have launched a map server, which is providing the map that we've done in the previous step.
Mm-hmm.
And we have made a small script that is called spot recorder. With the spot recorder script, we do not have to move the robot to a specific location to record it. We use RVS with the button 2D pose estimate
Mm-hmm.
to get the pose of the position of the robot and the orientation. This node subscribed to initial pose with a callback that convert the pose to a dictionary using utility in the YAML model in Pi. So we have a service called SaveSpot that waits for a custom message containing a label, which is the name of the spot to be received. When this spot name is received, it is watching if the name of the spot is end. If the name of the spot is end, it is saving the file and shutting down the node. Otherwise, it is managing to embed the new dictionary entry in the YAML data structure before saving it. So at the end, we have this result, which is a YAML file. When we have our node, we have the ROS parameter that are associated to the nodes. So we have the spots, and we have the 4 spot that we have described.
Mm-hmm.
So just having a small demonstration of that. So here we go. We start the node. We define the first spot, a second spot, third spot, then end, and we have our data recorded in a YAML file. So that's about it. We have a map. We have recorded points where we want to go to, but we have to set up the navigation stack to be able to go to these, to use these data.
Right.
So first thing of all is we have a launch file that is doing the localization. This is a localization launch file. It is starting 2 nodes. The first one is the map server that we've already seen, that is supplying the map for the robot to deal with. And we have AMCL. EMCL localized the robot on the map using the odometry, the laser scan, and the map. It is finding the most likely place where the robot should be. And it is improving its estimation as we go to, as we move the robot, it is improving the result.
Mm-hmm.
So for this, we have a special YAML file, which is a configuration file, where we use mostly the default setting for this nodes. But we have set in the robot the initial pose at 0, 0, because the simulated robot is starting from this point. So
Mm-hmm.
we just didn't want to do that every time. And we have the lifecycle manager, which is basically managing the startup, the various status of these two nodes. So this is the first thing we do. We start the localization, so we have our robot pretty well localized on the map. Then we have to set the path planning with another launch file, which is launching 5 nodes, basically. The first one is the path planner. The path planner is providing a global path from the current global location to the goal, avoiding obstacle known from the global map that has been made from the map that we've done already. So this is the one with the fixed obstacles, the ones that do not appear in real time, I guess. I mean. So we have a second node that is the controller server that basically it is locally managing the path along the global path. We want to stay close to the local path, but we can have nearby obstacles that are seen by the laser that we just collect on a local map pretty close to the robot. This map will contain objects that were already defined on the map, but that are seen by the robot.
Mm-hmm.
And it will also have new object that can be on the way of the robot. It can be someone getting on the robot, can be something, an object that have been placed that was not originally on the map. So the controller is taking care of that to make sure that we avoid these obstacles.
Right.
Then we have the BT navigator. Basically, it is the chef d'orchestre. It is managing all the other nodes with the behavior tree. And we have the behavior server, which is managing special motion of the robot when the robot is blocked on its way to the destination. Maybe something went on the way, and there are a few options that we can have there. Can wait for someone to get out of the way. You can back up a little bit and try to find a way to get around this object that is blocking the way.
Mm-hmm.
Can turn around to make sure that there's another way and redefine the map and things like this. And we have the lifecycle manager. Basically, it is managing the 4 nodes above. It is managing the status of these nodes. Basically, this is internal management of the various nodes.
Right.
And we have basically we could have 4 YAML file for these nodes, but we have considered all these parameters in one single YAML file. This is one way of doing things. Can be other ways, doesn't really matter, as far as you have every parameter required for the 4 nodes that we have above. And basically for this, we also started for default configuration, which works for most of the time, but we did a few adjustments. The first one was to improve the resolution, have the same resolution that we have in the mapping, which is 1 centimeter instead of 5. And we have adjusted the radius, the inflation radius that we have. Basically, an inflation radius is kind of protection zone that we have around objects. It can be around a wall or around an object that we have in the way of the robot. So we want to get not too close, but not too far from the objects. If we have too big radius, basically there's not that many places that the robot can move. And if it is too small, we can have an error and the robot can hit something. So we set it to the radius of the robot, which is a good a good estimate. And the other thing that we've changed is the XY goal tolerance. It's how close to the goal do we want to go to tell that we have reached the goal. It was at 0.25 meters, so we reduce it to 5 centimeters. So we're getting pretty close to the goals where we want to go. So now we have our robot that is located. We have our path planning that is ready to do its work, but we need a small script to send the goal to the robot and to make sure that we're monitoring the way it is going to do that job. So we have a go-to-post script that is sending the post to the name location, which is corner 1, but it can be anything we decide. And we have the spot file that we have done already, which is spotless YAML. So this script basically manages the parameter from the spot list. It retrieves all parameters. It is reconstructing the spot dictionary. It is getting the pole, the right. This is where we want to go. So in this particular case, it's corner 1. And it is getting the particular data for that node. It is creating a post temp message for the goal post, and it is sending the goal to navigate to pole action server. And navigate to poles is part of the NAv2 stack, and basically it needs a starting point and an end point, and it will just manage the way we go from one point to the other, sending feedback. The feedback is there. Okay, so we see that there are many points of feedback, but I just track this one, which is the distance remaining. And I also track the status. So we had the navigation succeed, but it could have failed. So we could have feedback from that. And we basically, this is the feedback that we send to provide it to the user. So this everything that we've said there, this is what we've seen in the, we have this small demo. So here we go. We launch the localization, the path planning, and name, we send it to the corner. Same thing that we've seen with the real robot.
I'm sorry, I don't know if we have enough time, Francois, but maybe could we see another, on the real robot, another spot that you recorded it? You have like 1
Yes, no
minute
problem.
probably.
Here we go.
Interesting to see.
Corner 2. Oops, not 21.
So at that point, we should see
yeah.
the robot. All right, it's moving to the.
Oh, okay.
All right, it got around that obstacle. And then the other obstacle.
Yeah.
Awesome. And I'm assuming that corner is on the other, that one on the top left. Oh, there we go. Ended just in time, just before I wanted to see that. Great. Awesome. I'm sorry to interrupt you, Francois.
Okay, so what happened yet? Oh, everything is dropped. Do you have a reconstruct starting?
Well, your session just ended. There we go.
Okay. So, okay, so the last point, okay, the real robot, what we've made to make it work with the real robot, just a few adjustments. Basically, we have made just the same file names, except that we have added real to have a real version. So we add a real version of the map. Okay, and we modify the MCL and the path planning YAML to place use sim config to false to have the real time of the robot, not the simulated times. And in the launch file, we also add the simulation false, and we refer to the YAML real file instead of the YAML files for the simulated robot. So this is what we've made, and we've seen that it is working pretty well. Any question and answers? Oh, answers to me.
Yes, awesome. Well, yes, I do have some. But first of all, let me congratulate you. It's really nice really nice presentation. Very clear, and I like how prepared you obviously were. And that's always appreciated for a clear explanation. So congratulations. I really liked that. I really like how you used the ROS2 parameters. Once you do the spot recording, how you can load them up in your script to go to that place already using the raw syntax. That was very nice. Um, so a couple of questions I have is the first one is, well, they're comments, but I think they're very helpful. So one thing I noticed on your Arvis is the laser scan messages. So the red dots seem to get stuck in the visualization. So you had all those messages that eventually can really confuse your
Yeah.
debugging. And RVis is mainly for visualization. And I think the error there was that you had keep messages. So in your laser scan element, when you add an RVis, you know how you can set them up. There's one uh, section that's like keep messages, and I think
Mm.
you can raise that up and lower that. And I think it was really high in yours, and that's why it stayed there, because the idea is for when it's
Yep.
easier to see with only one laser scan
hmm
element.
I tried a few things, but did not get good results. So, and it was a kind of short of time, so
Yeah,
I
yeah, and
leave it
this
there.
is
But
only a visualization thing.
mhm,
So, I
yeah,
mean, your NAv2 stack doesn't really care about it. It's just really
Mhm.
like because at the
Yeah, I know it
beginning,
was not good looking.
in the beginning, it was hard to see. Are we localized? Are we not?
Mhm.
And um, I think that's why it failed. That first time we you tried
Yeah,
to send it, it failed the goal.
mhm,
So just a comment for that.
no
And
problem.
one question I have is once you save those spots with the initial pose button on Arvis, do they get saved as a YAM file that you showed already with the like as a ROS parameter YAM file already with that format, or do you have to do extra processing to to put that YAM file in there?
Oh, there is extra processing related to that. Used pile YAML. Okay, basically what we do have in the code, I will go to the code.
Uh huh.
Okay, basically we're building the structure. Okay, here we go. Source. Where's it? Nav2. Nav2 project. Go to pose. No spot. Okay. Surf, we build a structure with an empty spot list
Mm-hmm.
here.
Ah, nice.
Okay. Then we convert the post to basically when we subscribe here, where is it? We have a subscriber here, callback. Where's callback? Okay, self post to dict. So we get this post in a dict here. Then we add the value of the dict. Here it is. It is. I guess it is around here.
Yeah, I understand
Tempo
now.
post. Yeah, it
You have
is.
like
We
a
just fill
skeleton
it in the. We just fill it in the structure. We just
using the
add them
YAM.
one after another, and after when we save everything.
Awesome, great. That's really helpful to use that YAM library for these things, because then you
Yeah.
can do the skeleton and then fill it up.
Mhm.
Nice.
But add a problem in the go-to post. Uh, I had to use these two, which was not obvious. I found it hardly, but because the name of the various parameter are not known because you can add spots.
Right.
Right, so you have to allow undeclared parameters because if you add a parameter that is not defined in the structure,
It'll get an
uh,
error.
uh, so in this way you can add as much. We have 3 spots, but we could have 20 spots. It doesn't bother.
Uh-huh. Okay, nice.
Uh,
And the last question I had is, so it's not like a question, but more of a thinking of how to solve an issue. So, for example, when we saw in the beginning that failed goal, uh,
mm,
that at the end, pretty sure it was because it was localized correctly, and the whole system depends on being localized correctly. So, how would you do? How would you do it in your go-to post script, right? In that script to handle
there.
the failure, and I don't know, maybe retry it,
Try.
or
Okay.
how could you do that with?
Uh, okay. Basically, here we go. We have the status. Okay. So we checked for status succeed.
Yeah, exactly.
Okay. We could have an else for status failed. Basically, we have an else that is navigation status failed, but it was not what has been sent by the node. So in this particular case, I don't exactly know why we since we really failed. How come this one did not fire? That I cannot explain. But we could have a retry something like this
Yeah,
at this
yeah, of
place.
course. And
Mm,
there are also some, I also wanted to mention some recovery behaviors that
mm,
the NAv2 stack has. They're not
yeah,
that great, so that's why I asked. You know, sometimes you'll see the robot spin, right?
yeah.
When maybe it's lost or something, it's because a recovery behavior
Is happening.
kicked in, right? But if that
Yeah,
doesn't work or it ends up too quickly, you can use that action goal that you sent, and based on the result, I don't
yeah.
know, maybe.
You we could cancel and ask for
Right. You could do tons of things. You could, for
yeah,
example, I'm thinking just, I mean, the easiest thing for the robot to get localized in my
it's turn around
experience,
itself.
just turn around 5 seconds, five the other, try again. I don't know, try
Mm,
5 times. Yeah. So I just wanted to ask this to make sure you get all the toolbox sort of that ROS2 offers in terms of
mhm,
actions, and how you can deal with them. Uh,
mhm.
but
I had to manage that a little bit. It was not that clear that first time it was I had no management of the final status, so I had this one, but it's not necessarily something that is right very clean. But when we have a real robot in a real environment
yeah, and
doing
it's
a real
all
job, we need to have a clean job in every situation.
right. You can always do it as much. I mean, you could spend a year more in this project to do it absolutely as robust as you can. But
Yes.
all right, well, that's all the questions I have. Thank you very much, Francois. Very nice presentation, and I just want to, give you a round of applause and congratulate you again for a really nice
Th-
job.
Thank you. It's been a good experience for me to have this presentation.
All right, I'm glad to hear that. So let me just switch back to my screen here. And yes, guys,
Uh,
so this is what you
okay,
can
stop.
do when you are done with our courses. When you complete our courses that offer a certificate, you can actually do one of these presentations with us to showcase all of your learnings in our online courses. So I invite everyone else that is watching to do the same, and come here and present what you've got and with our courses. That's it for us, guys. So we'll see you next time for our next presentation here at Becoming a ROS Developer. Bye bye.